The second panel is organized by BIC, the Building Innovation Cluster, which is a cross-industry network in Upper Austria, focused on boosting innovation and competitiveness in architecture, construction, and related sectors. So I would like to dive into the next topic, which is a matter of architecture, new processes and solutions for green buildings. And I'm very much looking forward to introduce the next speaker. He is the head of international timber projects at Rebhahn Timber Construction. Please welcome Johannes Rebhahn.
Yeah, welcome everybody. I will talk about how you can build in timber and what can you change if you build with timber. I'll start with a quick introduction of my background, of Rebhahn. Then I try to give you at least one reason why to build in timber. And then let's have together a journey to a lot of projects that we have done in the past that you see, okay, what can be done and what will be possible in the future. Yeah, we name ourselves as the pioneers in timber engineering, simply because we are the pioneers in timber engineering. We do that since 175 years. We are now in the 5th generation. And we started as a small carpentry, and now we are in acting worldwide with the hugest, largest timber structures in the world. We are still in a small village in Austria and working from there and serving all around the world. Since ever we had luck and the capability to make the most impressive timber structures in the world. For instance, that one built in 1966. It's still existing. It's an exhibition hall in Klagenfurt in Austria, and it has a free span of 100 meters, which was for a long time the longest free span in timber structure in the world. Then we made a lot of other new projects, crazy projects that you will see afterwards, that lead then also to the decision to make a new line for our factory, because we have realized timber goes also vertical since a few years. In former times we talked about long spans, huge sports halls, things like that. But since a few years you can make skyscrapers, you can make high buildings made of timber, and that led to our decision to make a new line for this kind of product. We have a quite holistic approach when we talk about timber construction. So we're not only a manufacturer, we help the architects if they come with a sketch on the napkin to us, and if they're asking, Johannes, is that feasible? How much does that cost? We help them. And if that sketch looks at the first view very brave and almost impossible in timber, we are even more motivated. We like that. We like, let's say, in a positive way, naive architects who make their lines, and then the industry have to solve it, have to solve the problems, because if we make always the same what we can, it's quite boring. It takes then normally a few years from the first assistant to engineers or architects until we really secure a contract, the order. And if we have that, then we do the full structural analysis. So we have in-house engineering, 25 boys and girls working on the computer and doing the structural analysis and the fabrication model. We obviously manufacture the elements, we have a project management, and we ship it wherever you want, and we install it then also. So that just to get a picture what Rebhahn can do. But why to build in timber? We are in Austria, in Vienna. In Vienna there are probably not too many trees, you haven't seen too many, but 48% of the area of Austria is covered with trees, with forest. So that's a good base. And Johannes talked already about CO2 emissions and building environment. 12% of the worldwide emissions on CO2 are coming from building materials. That means that comes from cement and steel. So that's quite a lot. If you think that all the aviation, all the airplanes are having only 2 to 3%. Of course, one solution would be to build less, as Johanna mentioned also in the previous talk, and that's really a good idea, and to refurb more and so on. But another another possibility is to build in timber. Because 1 cubic meter of glulam has a negative emission of 677 kilograms of carbon. So that minus is positive for the planet. The values for steel and concrete, even if they are green concrete and green steel, they are in the positive side with a plus and much, much higher. So this is one point or one trick how you can save the planet in a way. Beside that, of course, there are many other reasons to build in timber, which you will see afterwards. It looks good. You should feel good in a building. Nowadays, biophilic design is very common, so architects realize that the mood of the people changes if the architecture changes, so you should live in a nice building, in a nice office, and other technical reasons. But I'll lead you simply through a few projects for which we are famous. We call them the signature projects, like the Macallan Distillery. The Macallan whiskey is one of the most expensive whiskies in the world, and they decided to make a new building. They have chosen Pritzker Prize award-winning architect Richard Rogers to make that very, very complex roof. It's probably the most complex timber roof in the world. It's a real cathedral of whiskey, but also a cathedral of timber. So whenever you're there, it's 1 hour to the west of Aberdeen. You can't miss it. It's #1 visitor attraction already. It's hard to get the feeling over the slides here, but if you're there, don't miss it. It's really a wonderful masterpiece of timber. We worked with Norman Foster on a very long structure, 300-meter long, in the center in Canary Wharf in London. It's a public building, so you can see it, you can walk it whenever you're in London. It's easy to access, and a beautiful combination of a landscape garden with an open timber roof. We did also something in the Middle East. Once again, it's a record-breaking project. It's the longest and biggest timber building in the Middle East. It's a kind of shopping center and ice hall in the desert. So it's a real amazing structure, 105-meter diameter span, a very efficient structure, just a very small amount of cubic meter per square meter, and also easy to ship because they're just a few or very short elements, so no troubles on the logistics. We worked a lot for many posh colleges like that one, for Eton College, where it's simply important to be also sustainable and to have a good quality and a nice feeling inside. We worked with another star architect, Kengo Kuma, on the Hans Christian Andersen Museum in Odense, a very small one but very complex job where we proved again what's possible in timber. Kengo Kuma has a quite nice quote. He says, timber is the mankind's oldest friend. Therefore, he likes to build very much in timber. All of his projects are made in timber. This is also quite a beautiful structure. It's the Freeman School with a kind of whitewash coating, a very neat and clean design. You don't see any steel parts, and you can see here the beauty and the very easy architectural trick or gadget of making a diagonal ridgeline gives that building simply, We finished that job in Jerusalem with Faro Partners, a Canadian architect who is an expert on biophilic design, and he realized that you can change the mood of the people, and this is a cancer center, so people who are walking in here are definitely not in a good mood, but if they see that building, it cheers them a bit up, and therefore, they spent the money for that building to have a good architecture here. That's our current baby, the world of Volvo. I was in Gothenburg last Friday for the grand opening, meeting the presidents of Volvo and the architects, Henning Larsens, and now it's open to the public. Volvo, you can imagine, their main material is steel. They make their trucks, their cars, all with steel. But their main and the most important building from the whole group is the new world of Volvo, a kind of meeting place, a place where where every time is something going on, where you can make exhibitions, and which contains, of course, also kind of Volvo showcase, Volvo museum. Just to give an idea what we're able to do, this is a structural model where we had to prove that everything is stable enough, where we had to make our connections. 2 engineers worked on that for 2 years. In addition, 2 CAD people, so 2 draftsmen worked in addition 2 years to make a fabrication model, which shows then every screw and every flitch. Yeah, a few further pictures. You see that signature detail, I would say, a corner connection with very high forces inside. So you see timber design, timber engineering means also steel engineering, because you have to transfer high forces from timber to timber, and that doesn't work with a few screws from the DIY shop. You have to design it really, and you have very long screws and very heavy steel parts also. For instance, this is the most stressed connection. You don't see it really. The architect decided to leave at least a small square visible in steel, but inside is these 3 star nodes of that building. Yeah, I tell you, that turned out as a real beast. It looks like that. So really heavy connections, but that gives you simply the trust that you can make almost everything in timber, within reason, of course. Yeah, you see, we put our smallest engineer to the biggest steel node, so it's really impressive what that means behind the scenes. And these are now the finished pictures from the opening. There are plenty of videos and pictures, of course, especially nowadays, as this weekend was the opening, so you find it easily on the web. Yeah, working with that celebrity architects, rock and roll architects, is a big honor, is good fun, but it means also no compromise. So if they want a shadow gap, they get a shadow gap. So that's what we learned, but we still like to work with them, and it's really a big honor. But if we would work all the day with them, I think we would get crazy. We need also to relax. We need to have also more simple structures, for instance, like that. We can relax by doing the biggest glue lump job in the world with more than 13,000 cubic meter. Probably doesn't say too much to you, but it's by far the biggest glue lump job in the world. It's a logistics center for Edeka, German food chain, where you see very hybrid concrete and timber in combination. 100,000 square meter says maybe more to you, a real huge warehouse. We did another one in Dublin, which is currently growing or almost finished. So you see the beauty here. So you can imagine these buildings are not done because they will be seen. Only the forklift driver will see the timber. It's about sustainability. All the big logistic companies also have to prove, of course, their carbon footprint, their CO2 per square meter for the building. And by choosing timber, you tick that box quite easily to get all your certificates that you need. But now the main reason why I'm here today is talking about tall timber, because that's maybe new for you, and this is the big growing market and where we can help the planet maybe most, because this is the very easy to change, let's say, 1 or 2 buildings in every city in the world from steel to timber. To understand that, these high-rise buildings, multi-story buildings, need 2 elements. One is glued laminated timber, which is mainly used for sticks, that means a column or a beam. And the other one is named cross-laminated timber, which is a panel, can be used for a wall or a slab. These 2 names are mixed quite often in the wrong way or whatever, and then you have names for these 2 items together. So if you talk about mass timber, solid timber, mass engineered timber, then you mean both of them. Just a bit of education in the background. I told you at the beginning that we are the pioneers. We proved that again. We built the first multi-story building in timber in 2007 already, many years ago. It was a building that looks like nowadays. It's a glue lump column, a glue lump beam, and a cross-laminated timber slab. The same system as nowadays high-rise buildings made of timber are done. But then, 10 years, nothing happened. The world wasn't ready for that. And then around 2016, 17, architects and clients were ready, and now it's almost normal to build a timber building. I mean, it's always the first in Amsterdam, the first in Sydney, the highest there, the highest there. It's still a pioneering time, but there are now many samples around the globe. We have done Australia's tallest office building in 2018 in Brisbane with 55 meter. Looks really great. It's a complete timber building, so even the staircase and the lift shafts are made of timber. And you see how that building looks like. So open mechanical and engineering services, normal grids, let's say 6 by 9 meter, similar as on steel or concrete. And that's how nowadays offices should look like, you know. Bio-based material, fancy furniture, open spaces. In this kind of buildings, people want to go to the office at least for 3 days and be only 2 days in the home office. So you need to attract your employees nowadays to come to the office. You can't do that in a very boring building. We did also Asia's largest wooden building, again with a really huge amount of containers. More than roughly 400 sea containers were going to Singapore. You see that building. It's only 6-story height, so not really tall, but really huge in the shape of a crescent. And it's also from the structure itself quite ecological with a lot of natural ventilation, so the wind can go through the building. You have a lot of open spaces designed by another rock and roll architect. It's Toyo Ito from Japan. And of course, PV, rainwater harvesting, grey water reuse, and all these usual things that you have nowadays on a sustainable building. And it will be awarded today evening here for the Austrian Green Planet Building Technology Award. And yeah, we are proud that this is another award for that building. By the way, all that buildings receive a lot of awards in different categories in different countries. That's how a typical timber column looks from a close-up in our factory. So it's still not a furniture. You know, it's a structural element. It can be rough, but it must be very exact. It must be very precise, plus minus 1 millimeter, because everything has to fit together. And the surface is, of course, also with a kind of aqua varnish, but not a lacquer. But just to give you an idea how these things looks like from the factory. This is the typical style of a timber building, high-rise building nowadays. It makes sense to make staircases and lift shafts in concrete. That gives a bit more lateral stability, especially if you're going higher up and higher up. But all the vertical load path is done by timber, columns, beams, and cross-laminated timber slabs. You see here a lot of screws are required to achieve the diaphragm action of the CLT slabs. And yeah, here we celebrated, I think that was the last container going to Singapore. It was during the pandemic, so we had COVID outbreaks on the ships. We were in the middle of the Suez Canal blocking, so all took a bit longer than we thought. But at the end, everybody was happy and a great result. And just a few pictures from that building here. You see that open spaces, some are double-story height, and a real good luck and especially a good feeling for the students if they're there. Yeah, we did also the tallest timber tower in the world so far with 88 meter. It's very high in timber, not high if you look to or compare to a 500 meter skyscraper somewhere in Abu Dhabi. But in timber, it's really high, 19 stories of timber. Again, a bit hybrid. The park deck is made of concrete, and then you have 19 levels of timber, and also the staircases are then in concrete. As said, a very rational, sensible system of building nowadays. You see the rendering on the left-hand side and some way through the construction stage on the right-hand side. That's how it looks normally during construction phase. So you have to temporarily prop the columns. You have to take care about temporary water management. Therefore, you see that brown ceilings on the connections of the different panels. And we have to get used to pictures like that also carpenters are working not only in 8 and 9 meter height, that they are really working in 100 meter height over the skyline of any city in the world. of course, they celebrated very much then the topping out party in Milwaukee. And it's already finished. You can even book a room via booking.com there. It's an apartment building, but some are rented for tourism. So really a nice building. There is a kind of authority who are the referees looking over the match who has done the highest building in all categories, also in the traditional steel and concrete. And so they got the certificate for the highest timber hybrid building so far. We did also a lot of jobs in Germany. This is, of course, the first one in Frankfurt building. I would say this is then the mass market in the future, 6 to 9 stories in that 5 million inhabitant cities where you need still a lot of office or apartment buildings. We did a nice one also in Amsterdam, finished 2 years ago, 25,000 square meter for a media house close to the water, as everything in Amsterdam. And they are just going in and starting to run that office. That's also one picture of that building. I always tell the architects and the clients, don't make a Swiss cheese out of our glulam, but they don't listen very often. So it's always better to have the M&E above in a raised access floor or underneath the beams. But yeah, if they want it through the beams, it's possible. It simply costs a bit more money. The next one that we will do in Amsterdam quite shortly is the Cube House, a nice, sexy corner building in Suida, part of Amsterdam. Again, they look all from the structure quite similar. A few stories in concrete, staircases in concrete, and the rest is completely in timber. So you can save a lot of CO2 emissions by making this hybrid system. And these are the usual keywords. This is also for the Cube House that you see in all that buildings. Bio-based material, any BREEAM, LEED, whatever certificate, excellent, gold, platinum, Paris-proof, a rooftop garden, reuse of grey water system. So all these buildings try to tick all the boxes, and by choosing timber, you simply have it easier to achieve all the targets. And that's the next world's tallest timber tower, also done by us. We are currently in the design phase. It's a big step from 88 meter to 182 meter. It's the Atlassian Tower in Sydney, a real timber needle in the sky, where you see it's again quite hybridy, even with some mega floors. So the timber is here not the limiting element. You could build it also 500 meter because the primary structure is still steel and concrete. And then you fill in 4 or 5 levels always in timber. So the amount of timber is still very massive, a lot of timber, but it's not a stability problem. And I end with a few pictures of that project that you can imagine, okay, what brings the future, what is possible. And I hope that I opened your eyes a bit, that you realize now what can be done in timber. As said, it's just one way to save the planet, but it's a good way, an easy way, and we and the rest of the timber industry is ready for that. Thank you. Thank you.
Thanks a lot. Thank you very much, Johannes, Rebhahn. Thanks for sharing these truly impressive pictures with us. Thank you so much. And of course, we prepared another very interesting presentation for you, and I'm very much looking forward to introduce the next speaker, who is the CEO at Synthetic Dimension GmbH. Ladies and gentlemen, please welcome Martin Huber.
Hello, everybody. I have a good afternoon. Some impressive projects in hardware. Thanks a lot, Johannes. Now I would like to invite you into a journey more into the digital world. So we will talk a bit about data, around 3D capture, but also about the building information model, which is a crucial component when it comes to existing buildings. So 80% of all the buildings that will be there in 2050 are already built. So we talk a lot about new buildings and all the possibilities with CAD programs, but in fact, most of the buildings are already there. And what's really interesting there is we have almost no digital data about these existing buildings. Before we go into this more, I would like to invite you to a small journey around what kind of data do we really want to have about these buildings and why do we need it? So first of all, the buildings we have today, they consume a large amount of energy. So 60% of global energy consumption is coming from existing buildings. And depending on what types of buildings you look at, around about 20% of this energy is coming from artificial light. And what's also something what we don't see but what is surrounding us everywhere is wireless. So 5G private networks, access points, they also produce a large amount of, or consume a large amount of energy. And for all of these things, we need 3D data to plan them. For some of them, we just need 3D data because we can do it more efficiently, but there is also parts where we need 3D data to do it in a regulatory right way. For example, there is a regulatory to do light planning in Europe, and you need 3D data to do it. So for light planning, it increases the efficiency to have 3D data, and also the EU is doing a lot on the regulatory segment to also improve this. The second thing I want to dig into a little bit is 5G, 6G technology and why we need 3D data to plan this out. Also, facility management is coming more and more into the 3D space. We are working with a company in Switzerland, and actually they are losing 6,000 chairs every year. No one knows how this happens. They are just, I mean, they are not stolen, they are somewhere, but they are lost in the system. So they want to track it. And also, of course, there is this huge part of interior design that also goes into existing buildings. Now, we've heard about the building information model. The building information model is a regulatory standard. Actually, 2 weeks ago, the IFC 4.3 format has officially become ISO standard. So there is good news. There is a data standard for buildings. And everything we do, and also I think that the global digital environment around architecture, engineering, construction, it will go more and more into building information model. When we look at, for example, at a country like Norway, we do see already coverage of 50% of building information model when it comes to buildings. There are not exact numbers about the DACH region, but I would say from the numbers you hear on the market, it's maybe 5 to 6% of the buildings that are planned out with building information model. So this comes more and more, I think. For sure, you have also heard about digital twins. This is something that can build on top of 3D data. So the difference here is from a specification or standard view, you would say it's a virtual representation of a physical object. It's also now standardized in ISO, and it says it has to be updated with real-time data. So that's a little bit the difference to 3D data. So it's updated with IoT. We don't see too much here in the market. I think it's more kind of a concept. We see a lot of big companies talking about digital twin. But I think what we really see on the field is still very low. There are maybe some lighthouse projects, and it also builds on top of 3D and building information model. Yeah, this is a picture, and sometimes I remember these COVID times where everything was about the metaverse, also Facebook renamed and all of these things. It was even, I think, in the Zeit in Bild at some way, what's the metaverse? I don't see any kind of, movement into this anymore when it comes to building and 3D. But what we see is that a couple of companies are promoting the industrial metaverse. So this would be something like Omniverse from NVIDIA. Also, I think Siemens is talking a little bit about this. This would be then, if you take a look at it in terms of layer, it would be 3D, and then it's building information model, and then it's a digital twin. And if you connect more digital twins, and you work with many of them in a digital space, then this would be the industrial metaverse. Also more applied to factories today, I would say. So this was more the theory part, just to make sure that we're all on the same page. The opportunities and the challenges when it comes to 3D data in buildings are quite high, I would say. So opportunities are high, but also the challenges are high. When we take a look at improving workflows, and Joanna has talked about this complexity. So when we do a 3D model of an existing buildings, in many ways it looks a little bit like this. So we have like 1,000 icons, and it's expert work to do it. So to go into this digital world is, in many cases, it's very complex, and it's expert work. And I want to talk a little bit about how can we simplify this, and what's maybe also the future of this technology. And what helps us here is AI. AI has not only made tremendous jumps forward when it comes to large language models. Probably every one of you knows ChatGPT and even is using it for the daily work. But also when it comes to computer vision and the understanding of 2D and 3D space, it's going for the last 20 years and is driven a lot by autopilots from cars, but also from many other industries. How can we understand the world around us better using AI? And everything you will see after this slide is basically based on AI. Now, but this also brings up a pretty interesting problem. There is a homepage, it's called AI in AEC, so the AI in the architecture, engineering, construction. And there is a list of AI-based tools. And today, I think, I just looked it up before the presentation, there was 1,057 AI-based tools for this industry. So who can use this? No one of us has the time to dig into more than 1,000 AI-based tools. So it's a large amount of companies are also now popping up, building on top of AI products, like layouting or add-ons to AutoCAD and Revit and things like this. It feels a little bit like in the right side, so the technology is moving so far, it's very hard to catch up. So like every day 10 new tools pop up, and how can you even catch up as a human being with limited time? And I think that there will be some kind of consolidation. So there will not be 100 layout tools. Maybe there will be 2 or 3 that are really good. But what we see today is kind of an explosion in AI tools around this. One of these tools I want to show you today, and actually our company is working on this for 4 years. It's an AI-based 3D capture that not only captures the geometry of a room, but also it has spatial understanding. So if you move around the mobile phone here, you will see that it will identify automatically parametric models and parametric surfaces. It will not only understand what's geometry, it will also understand what's a window, what is a table, what is a chair. Now, this technology will help us a lot in the future to get plans out of buildings that already exist. This use case we are doing here in this video is actually for light planning. So for light planning, also ceiling elements are important. So we can take a look at them and additionally book them into our 3D model. By the way, everything you see here in this screen record is only for user guidance. The final model will be calculated after we finish the scan. Now we click on stop and we receive an intermediate result of this room. And we can take a look at it. It will ask us, did we capture everything? And these 3 dots here are the 4 light positions of this room. Now, this is only one room, and it's a very simple room. But what's also possible today is we can just continue the scan, and we go to the next office, and we can add another scan segment. And basically, this is today unlimited in horizontal and also in vertical space. So you can build up a complete model of a building just using a phone. Now I want to save a little bit your time and go to the next slide here, as this is just repeats the first scan. So everything you have seen here is working very close to an autopilot of a car. And sometimes when people are looking at AI, it feels a little bit like magic, or it's very hard to understand what's happening. And it's very similar to autopilot in cars. It's a lot of different small AIs that are very good in understanding one specific thing. So for example, one AI just is looking for doors and windows. Another AI is looking for chairs. A third AI is looking for colors. And a fourth AI is looking to get the basic understanding of the room. So if you add all of these things together, you will end up with a complete understanding of the room. Now, I mean, 3D capture is here for, I would say, 20 years. So you can do it with big laser scanners and then do a reconstruction on Autodesk Revit or something like this. The difference to this technology is that everyone can do it. So basically, there is no kind of onboarding and no kind of expert training. So this can be downloaded from an app store, and people use it from the very first second, and they can create data. And I like this a lot because it democratizes something that has been, basically has been close to a very small group of people that has been able to work with this expert equipment, and now every one of us can do it. And I think this brings a lot of good into these industries. And we can see it a little bit here in this picture, and sometimes this reminds me on what we have seen with cameras 20 years ago. So I remember being at, I think at that time it was MediaMarkt, and you go into there and you see all of these high-end analog cameras, and you can see this early stage digital cameras. And at that time, everyone laughed about digital cameras because they were just bad. And now, if you look 20 years later, you can do a picture with an iPhone or an Android phone, and it's due to software, the quality of the pictures that come out are even better than with analog cameras. So that's quite crazy. And exactly the same happens to 3D understanding. There are some use cases already when we focus here on this area where accuracy is not super important. So if we go into bath planning and kitchen planning, where we go into the sub-millimeter space, then this technology is not there today. But what we can see is that from year to year, this becomes better and better. Actually, when we started 4 years ago, the accuracy was around about 20 centimeters from wall to wall. And today, we are already at 2 to 3 centimeters. So it just improved so much in 4 years. If we go into this linear direction and project this into the future, we already know today that in 10 years, this technology will pretty much cover everything. So in the light planning business, we are using this a lot. And actually, I would say more than 90% of the light planning companies in Europe are already using this to do 3D plans in light refurnishment projects. Here is one example. This is an object that is 60 meters in length, and it is 25 meters in width, and it has been scanned only using a mobile phone. It took round about 20 minutes to do it. It's 2 stories. And it was done in 3 scan segments, but everything has been built up automatically, just using an automatic AI pipeline. And this is quite, I would say, a complex building, as it is not very standardized. It's pretty old and has a lot of old components in it. And then if we have this digital model done, we have a digital library of luminaires, and we can put the luminaires into this digital building, and 1 minute after the scan, basically, we can see a picture like this. So we already have a color map of natural and artificial light, and we can also do renderings to show the owner that this light will look like this in this building, and also saves a lot of energy. Another thing is that we are moving more and more into 5G, 6G, and 7G. Typically, when we talk about these technologies, people think more about the outside of buildings. You have the antennas that are covering whole cities, but actually the technology is moving more and more to the inside of the buildings. So we are talking more about 5G private networks, and probably most of your phones are already capable of replacing the Wi-Fi to 5G private networks. So in future, we will have more and more 5G connections instead of Wi-Fi, because it's just more efficient to put one antenna on top of a building than have hundreds of small antennas inside every building. And I think all of you know there is always the spot where the Wi-Fi is bad. So this will be done with this kind of technology. But it also comes up with a problem. 6G and 7G is based on a technology that is named beamforming. So what the antenna does in real time, it finds your phone and focus the beam directly on your phone. And to do it, it needs understanding of the interior of the building. So also 3D plans for 5G, 6G, 7G of the internal aspect of the buildings will become more and more important. And this is something we are working with quite some companies already globally. This is an object, I think it's also in Salzburg, where we did a scan with this mobile application. It's a multi-floor scan. You can see it here. It has around about 2,000 square meters. And also there, after the scan, we generate a new kind of model that is perfect for wireless planning. And we give this data to another software where the radio planning can be done. And we will see the result soon. We just import, again, a building information model, so it's based on IFC data. And then you can put your access points and the Wi-Fi components into this automatically generated 3D plan, and already you can see the coverage of this and improve it if there is refurbishment work. The last use case I want to show you is facility management. This is also for us, I would say, new lands or new area, as most of the facility management software that is used out there is based on 2D plans. But what we see is that also this kind of software moves more and more into the 3D environment, because it's a lot easier to find assets and also to do calculations that are relevant for asset management and for facility management on base of these models. And also we are into some pilot projects here in this area. Yeah, that's pretty much of what I wanted to show you today. So it's a sneak peek into the future, but it's already available today. It's something in between, I would say. Thanks a lot for your time. I wish you a good afternoon, and yeah, have good success in your journeys. Thanks.
Perfect. Thank you so much, Martin Huber. Dankeschön.